suppose one situation is there. One situation we have come across here. A telephone company wants to place a relay tower, want to position a relay tower at point P between A and B. See, here is a positions A and B. In between these 2 points, there is a point P. They want to place a relay tower here. Okay, relay tower they want to place here. Okay, so now in such a way that the distance between the tower and the A and B points, distance between this tower and A and B, so it is given like this. B is twice its distance from A. B is twice distance from A. Suppose A is x means B will be 2x. A is x means B will be 2x. So that means it will be in the ratio of 1:2. Now what is this point you have to find out? So that AP is to PB will be in the ratio of 1:2. That is the ratio. So suppose if A is given, coordinates of A is given, coordinates of B is given, and the ratio is given, you can find out. You place this tower in the ratio of 1:2. Then you have to find out this coordinates x comma y. So how to find out this? I will show you now with a graphical representation with the diagrams. So this is 1:2. A and B are the 2 terms. So I have taken the vertices like this. A is at the horizon 0, 0. B is at 36, 15. Okay. This is B. Coordinates we are having. And I have to place this in such a way that it is in the ratio of 1:2. I told you AP is to PB. AP by PB is 1:2. In this ratio you have to place the tower. Tower position is this one. See, city A and B are the 2 places, and this is the place where the tower is to be placed now. So I have taken the same thing here. B, the vertex coordinates are 36, 15. That means from here to here 36, from here to here it is 15. And it is at origin. Origin means 0, 0. We want to find out this position here. For that, look at this. Here we have 2 triangles, right angle triangles, this triangle and then this triangle. Both are similar. I tell you why. This is the line drawn parallel to x-axis. This will be 90 degree and this will be 90 degree. Okay. So one angle is equal. So then, if you take this angle and this angle, corresponding angles are equal. So because these 2 are parallel, then these 2 becomes corresponding angles. So by area similarity, you can write triangle APD. Triangle APD similar to triangle PBC. APD similar to PBC. If these 2 triangles are similar, you can write the sides are proportional. Triangles sides are always proportional. What is AP and PD? What is the ratio AP by PD? We have 1:2. The ratio that we have taken, AP is to PB, we have taken 1:2. You substitute that one. Now what is PD and what is BC? Look at the diagram. PD is this distance. You can see that is Y. We have taken that as Y. This distance is Y. I have written PD. BC. What is BC? This distance. This distance can be calculated. This total distance minus this. Total distance is Y value 15. And minus this, it is Y. Because this is Y, this is also Y. Total distance, this is, see this one. 15, total distance 15. And this length is Y. Because this is Y. So what is this length? 15 minus Y. I have written here. Y divided by 15 minus Y. Okay. PD here, Y. So this also Y. And this distance, total length minus this one, total length is 15 minus this one that I have written here. Then AD by PC. AD here, look at the point A, D. AD here, from here to here, what is the distance? You can see first coordinate here, X. This distance will be same. So these 2 distances are same. So this is X. From here to here it is X. I have written ADX. What is PC? PC is same as this one, D. This distance is same as this distance. Okay. This how you will calculate the total distance minus this. Total, look at this 36. From here to here it is 36, same distance. So 36 minus x. So I have written here PC 36 minus x. Look at this. We have made a construction PC parallel to x-axis, and you have the perpendiculars drawn here. So what happens? Perpendicular drawn means these two angles are 90 degree. This is also 90. By a similarity, you can show that these two triangles are similar. Sides are proportional, and the ratio AP by PB it is 1 by 2, and remaining ratios you substitute by looking the diagram. So once you substitute, you get this one, these two. You will get first and second one, or first and last. X 36 minus x is equal to 1 by 2. Simplify, you will get 12. Equate this first and second, this one, you will get the y value as 3. Cross multiply, y value as 3. The point is 12, 3. This point xp of x, y is nothing but 12, 3. So this is 0, 0. 36 is 15, 36, 15, and you are getting this 12, 3. This 12, 3 will divide this total length in the ratio of 1:2. This is one part, this is two parts, 1:2. So this, finding out this point, using this method, we have one formula. To find out this point, we have one formula that is called as section formula. Here 1:2, somewhere you can take 1:1, sometimes you can take 2:1, whatever the ratio. According to that you can find out using the formula that is called as section formula. Let us go to the section formula now. What is that section formula? How to find out the section formula now? Look at this now. All of you look at this. We have a line segment AB. Coordinates of A, x1, y1. Coordinates of B, x2, y2. So we want to find out point P. See, the point P is here x, y. We want to find out the ratio in which it is divided. AP is to PB I want. What is AP by PB? This is the ratio I want. In what ratio? This point is dividing the line segment AB. So ratio you are going to find out. Suppose AB here, I have selected on point P here. What is the ratio in which it is divided? So AP by PB I want. So let me take this as M1, M2. This is divided in the ratio of M1 by M2. AP by PB, let us take it as M1 by M2. So that I have taken here. AP is to PB is in the ratio of M1 is to M2. That means if this is M1 part, this will be M2. From here to here, M1 means here to here, M2. 1:2, 2:1, or 1:1. Like that we will take now. In the general form we have taken. So M1 is to M2. So now same thing we will do what we did in this case diagram. So let us drop the perpendiculars here. So let us drop the perpendiculars. What do you get? Let us see now. Perpendicular, let us take. Here also one perpendicular. Then from here also one perpendicular. So three perpendiculars we have drawn from this to find out the section formula. Let us take this as R, S, T. The points. All these three are perpendiculars. Okay. Then let us draw the parallel lines to x-axis from A and from B. We have drawn two parallel lines to x-axis. So you can take this as Q and this one as C. This is the construction we have done here. Okay. So you can write here what the construction we have made. So draw the perpendiculars. You can say draw AR, then PS, then BT, perpendicular to x-axis. Another one, again draw AQ, then BC, parallel to x-axis. So this is a construction we have done. This is a construction what we have done here in this case. So perpendiculars, three perpendiculars and two parallel to x-axis now. So now let us find out the coordinates of point P. We want point P of x, y. So you know that already triangle APQ. Triangle APQ is similar to triangle APQ similar to PBC. So by AA similarity, you can write this as by AA similarity. You can write these two triangles are similar because this is 90 degree, this is 90 degree, these two corresponding angles. So therefore by AA similarity triangles are similar. So you have proved that these two triangles are similar. Okay. So you can write this triangle and this triangle, they are similar. So these are the two triangles, they are similar. If they are similar, you can write the corresponding sides proportional. Look at this itself, you can write. So how you can write that one? AP by PB is equal to PQ by BC is equal to AQ by PC. So you can substitute the values similar to the previous question. AP by PB, you have M1 is to M2. You can write it as M1 by M2. There in that example 1 is to 2. Now PQ, you have to find out the value of PQ, this distance. PQ is nothing but, as I said, PS minus QS. Here QS is Y1. This is Y1. So this is Y1. Total length is Y. Y minus this. Y minus this is Y1. So you can write PQ as Y minus Y1. Are you clear? Is it clear to all of you? PQ is same as PS minus QS. PS vertical line Y. QS same as this. This is Y1. So Y minus Y1. So that I have written. Divided by BC. Tell me what is BC now? BC this much. Total length. What is the total length here? What is the total length from here to here? Vertical line. Tell me what is the length? BT is equal to. What is BT is equal to? So this is Y2. Total length is Y2. And this length is same as this one. So this length, you know, it is Y. So this is Y, means this also Y. Total length is Y2. This length is Y. So you subtract Y2 minus Y. So it gives you BC. So this is Y2 minus Y. Look at the diagram and tell me. See now PQ, you got Y minus Y1. How you got total length minus this one? Total length is Y. This is same as this one, Y1. Total minus Y1. Total is Y minus Y1. I want BC. Total length minus this one. Total length is Y2. This length is same as this one. This is Y. Total Y2 minus Y. So you got this. Now same way you have to tell me what is the value of AQ. AQ is same as RS. AQ is same as RS. RS are the 2 points on x-axis. It can be calculated OS minus OR. What is OS? This distance, horizontal, x value. What is x value here? It is x only. OS is equal to x minus OR. That means x minus x1. X minus x1. Look at this. This distance is same as this one. This how you can calculate OS minus OR. OS is x coordinate here. X1. X. This is x. Then OR is x1. So x minus x1. Similarly, PC. What is the value of PC? PC here, this one. It is same as ST. ST can be calculated as OT minus OS. OT here x2 minus OS is x. So here you can write x2 minus x. So this is a very important relation. We used to find the ratio also, M1 by M2. To get the value of x, equate the first and last. So x minus x1 divided by x2 minus, this is x. x2 minus x is equal to m1 by m2. Cross multiply now. Here m1 into x2 minus x is equal to m2 into x minus x1. Now multiply this one, m1 x2 minus m1x, m2x, m2 x1. Now what you do, keep the terms which contains x in the left hand side, other things in the right hand side. Otherwise you transfer this to the right hand side, m1 x2, then you transfer to the left side this one. So it becomes plus m2 x1 is equal to this. If it goes to the right hand side, m1x plus m2x, rearrangement only. See here m2 transfer to the left side and here m1x transfer to the right side. Now here you take common here in this right hand side. So what you will get, right hand side I will write in the left hand side now. X common if you take, m1 plus m2 is equal to x common, m1 plus m2 is equal to, so here you are getting m1 x2 plus m2 x1, m1 x2 plus m2 x1. Now x value you want m1 x2 plus m2 x1 divided by m1 plus m2. So this is the value of x. In the same way, equate this second and first, you will get the y value as m1 y2 plus m2 y1 divided by m1 plus m2. After simplification, you will get this one. You have to select these two ratio, cross multiply, you will get this one. So now the point which is dividing the line segment here, this point P is x comma y. So I will write in this way. That point P of x comma y, it can be written as P of x value. You write this one, m1 x2 plus m2 x1 divided by m1 plus m2, comma y value. This y value you have to write here, m1 y2 plus m2 y1 divided by m1 plus m2. So this is the value of P of x comma y, and this is called as section formula. This is called as section formula. So using this you can find out the ratio point P, you can find out. Sometimes they will ask you to find out the ratio m1 by m2 you have to calculate, or they ask you to find out the coordinates of one point, end points. So anything they ask, suppose here is a line segment A, B, and here is a point P, see A, x1, y1, B, x2, y2, then this is x comma y. What is the ratio they will ask? Sometimes then you have to find out m1 is to m2. Okay, so very easy to remember this one. P of x comma y is equal to, listen here, m1 into x2, m1 into x2, m1 into, from m1 the other side, this ratio the other side, plus m2 x1 from this to this, m1 to that side, m2 to this side, m1 x2, m2 x1, x value first, initially we will go to x value, m1 x2, m2 x1 divided by m1 plus m2. We want y value m1 y2 plus m2 y1. Very easy to remember. See this side ratio, first term, you go to that side. See m1 x2 plus m2 x1 divided by m1 plus m2. Y value m1 y2, m2 y1. So m1 to the other side, m2 to this side. So ratio given this you can apply like that. Very easy to remember. By this method you can remember the formula and write the formula wherever it is necessary. This is called as section formula.